Today we'll get started with Kubernetes, another container orchestrator tool. We already learned Docker Swarm yesterday. Today we are going to learn about Kubernetes, a container orchestrator tool. The other tools in this category are like Docker Swarm, Mesos we have discussed, right? So Kubernetes is very widely used and far advanced and very extensive tool. So what are the differences with the Swarm and all? First, let's look into the basic differences. Both are container orchestrator tools. And Docker is a product from Docker, and the learning curve is very simple. Like if you know Docker, the commands are almost simple as the Swarm commands are as simple as these are the product from Docker, and Kubernetes is the product from Google. So Kubernetes is a product from Google, and now it is managed by CNCF, Cloud Native Computing Foundation. Cloud Native Computing Foundation. And Docker Swarm, you don't have to install Swarm separately. If you install Docker, like you can directly get into the Swarm mode without any separate setup. Whereas Kubernetes setup, yes, it's a quite complex, and this setup varies from platform. Like depending on where you are setting up your Kubernetes cluster, the setup varies. Right. And also in Docker Swarm, the architecture is simple architecture, learning curve is easy. Here you have the architecture a bit complex. We'll get into the architecture today, like many moving components in the architecture. Right. And what else we have? Um, yeah, again in the Docker Swarm, you have high availability, load balancing, scaling, but you don't have auto scaling here, where Kubernetes have got auto scaling features. Of course, it doesn't come by default. We have to configure it. Auto scaling is there, and then you can promise zero downtime with the Kubernetes deployments. Right. So these are all the very small differences. Once we get into the actual hands-on and see, do the setup and all, you can see the actual differences with Kubernetes. 50% again in Kubernetes, like you on AWS or any cloud, each cloud offers managed Kubernetes service, right, which can help with all the initial setup. So with these basic differences, let us understand what is Kubernetes in more detail. First, let's get into the architecture of Kubernetes. I'm sharing the architectural diagram. Can you all see this? So Kubernetes cluster, like we have Swarm cluster, this is the Kubernetes cluster. Kubernetes cluster is bunch of Docker hosts, right? So bunch of Docker hosts. Here you can see as control plane, worker 1, worker node 2. Means Docker host, bunch of Docker hosts. I'm calling this as worker node. You can have any number of nodes, right? Those are all called worker nodes. I am having in this cluster as of now one worker node. This is one worker node. This is second worker node. So two worker nodes. And there is one master node which is called control plane of the cluster. Control plane is nothing but which will take care of the entire cluster. Right. So before, let's go into each component of the worker node. Again, worker node has got different components. The first one is the Docker. Right, if you want to run containers, obviously the container runtime should be installed, which is Docker in this case. So that's very pretty straightforward. So Docker should be installed. Then you should have kubelet. What is a kubelet? Kubelet is nothing but it's the main Kubernetes agent running on every worker node. Means your master node will interact with this worker nodes via this kubelet. So it's the most important component, the moving component, or else the core component, Kubernetes agent running on the worker node, right? So that is the one which helps in interaction from master to this worker nodes, right? That's the second component. And the third component is the kube proxy. Kube proxy is considered as network brains of the cluster. Means if network brains in sense, let's say how containers from one container to another container on another worker node communicate, all of that would be taken care by this kube proxy. I'm repeating again how containers communicate from this node to this node, or else how one container communicate to other node. All the communications will be handled by this worker node. Right? Is handled by the kube proxy. So these are all the three components: Docker, kubelet, and kube proxy. Those are the three components which reside on every worker node. Along with this, there is one more component called pod. There is something called pod on every node. What is this pod? Pod is nothing but a layer above your container. In a Kubernetes cluster, you will never see container like this. Meaning it's always wrapped with another layer called pod. Pod is like a shell or a home for your container. Container lives inside the pod. Pod provides a living environment for the container. Right? And also it's a basic unit of deployment. Means you deploy the pods, you scale the pods, you delete the pods. This is how you deal with. And the general practice is one container per pod, right? You can also have multiple containers per pod, right? Let's suppose this is your pod, a replica one. You can scale up, means another pod will be created with the same container in it, right? And then another container. Right. So you can scale the pods. Also, let's suppose if your pod is having suppose two containers. When you scale it, you'll get another pod created with two. So this is the basic unit of pod. And now you may be wondering, like, what is the importance of this pod? Like I told you, it's a layer. Pod will have some network interface. Container living inside the pod will share the same pod network interface. So what is the importance of this layer? Why should it have a pod layer? What is its importance? Anyone, any idea or any guess? Why should it have the layer of pod?
Is it because of the
Okay.
security?
Yeah. See here, this pod layer works like a layer of abstraction. Another difference which I have to mention here is Docker Swarm can orchestrate only Docker containers, whereas Kubernetes can orchestrate containers from any runtime, right? From any runtime. But there are different container runtimes, right? Like Rocket, OCI, and all. So any of them can be managed by Kubernetes. So that is one more difference. And pod is a layer of abstraction which can help you manage containers from any orchestration. right? It can help you manage, means the pod layer remains same whether it is Docker container, Rocket container, or OCI container. Understood? So that's the importance of pod layer. It works like a layer of abstraction to run any container runtimes. So these are the 4 components we have discussed till now, like Docker container runtime, container runtime, Docker, kubelet, kube proxy, and the pod. Were these 3 components clear? Any questions from anyone in these components?
Can you explain once again about proxy?
Kube proxy will take care of the networking of the containers, means communication, network communications will be taken care, right? It's called network brains of the cluster, right? This is one thing. And now we're coming to the control plane. This is the control plane, means master node. Master node is called the control plane of the cluster. As the name says, it is the decision maker. It's a main component. Again, it has got 4 different components like API server, scheduler, controller manager, and HCD. API server is nothing but the core component of the Kubernetes. Core component in the sense, yeah, core component is a main component which is a decision maker. And you run the Kubernetes commands, right? Kubernetes has commands you can run from CLI, or else there is also user interface also. But user interface is very rarely used, very less used. CLI is the component which we use. Whether it is UI from the GUI or from the CLI, whatever commands you run, they are fed to the API server, right? API server is the one which will validate your commands. And if the commands sent are valid, then let's suppose, okay, you have sent some command, it should run 3 containers. Then API server will validate those inputs, and then it will interact with another component called scheduler. Scheduler, as the name says, it is the component which will schedule the container. Means it will tell where to schedule a pod, when to schedule a pod, on which node, all of that will be taken care by the scheduler. Right? So this is the component which will schedule the pods onto the worker nodes. This will schedule the pods onto the nodes. It will decide when to node, and also not only schedule, just schedule, it will decide which node it should schedule. All of that would be taken care by the scheduler. And then comes another component called controller manager. Controller manager is like a watchdog of the cluster, which will have different controllers like node controller, pod controller, endpoint controller. It would have different controllers. This controller manager will have different controllers. It would run non-terminating or unending watch loops, which will check the actual state of the cluster versus the expected state. Versus expected state of the cluster. What is meant by actual state and expected state? Expected state is like, let's say you have run the commands to execute to start 3 containers. Actually, there were only 2 containers. So it would keep checking this. If there is any mismatch, like expected is not equal to actual state, it will send those commands. Means it will just interact with the scheduler, and scheduler will schedule that extra, that one more pod which is in need. Means controller manager will identify the discrepancy from the expected and actual state, and it will send the instructions to the scheduler. It will send the instructions to the API server, right? All of them will be working with the API server. API server will then send the instructions to the scheduler, will schedule the pod, right? Got it clear, everyone? So that's how controller manager will be keep on running those non-terminating watch loops. That's why it's called as a watchdog of the cluster. So this is how the 3 components work. And by the way, scheduler will schedule it, right? But how does scheduler or anything will interact with the worker node? With the kubelet component. Kubelet is the component with which they will interact. Is that making sense and clear? So those are the first three components. Then what is HCD? When API server is called the brain of the cluster, right? This is called the main one, which will validate the instructions, I mean the inputs and all, right? It's a brain of the cluster. This HCD is called the memory of the cluster. All the cluster configurations will be stored in the HCD. It's like a database where data is stored in the form of key valued pairs, means NoSQL database, right? Data will be stored in the form of key valued pairs. Whenever API server, scheduler, controller, node are all interacting with one another and scheduling, do you wonder how these components are getting all these values from the cluster? Like, how does controller know what is actual state, what is expected state? How does scheduler know on which node it has to schedule? Isn't that? How does they know? Means scheduler should know the available resources, the health of the cluster, I mean the health of the nodes. How are these components getting all that information? They get all of that information from the controller manager. Clear? Sorry, from the HCD. HCD is the one which will have all this information. So all these three components will get all this information from HCD. Right? So that's how they get the information from HCD to evaluate which node it has to deploy and all. Is this much clear, everyone? Understood?
Yes, ma'am.
So these are the different components. If you are clear with the architecture, we can talk about the cluster setup. Are we good? Any more questions from anyone? So, okay, as we understood the architecture, let us get into the cluster setup. Kubernetes cluster setup can be done in multiple ways on multiple platforms, like it can be done on on-prem. It can be done on any cloud, like on AWS or Google Cloud Platform or on Azure. By the way, one more thing, local setup called Minikube. Minikube is a single node cluster setup where even you can do the cluster on your laptop also. For your learning purpose, for the lab and all, this is a very good option. Now, coming to on-prem kind of setup, you will have some physical servers or VMs. You will configure everything from scratch and you do the setup, right? So this is on-prem setup where you have to set up the cluster from scratch, and you have different utilities called Kubernetes with which you can spin up the cluster with all the virtual machines or physical servers you have. This is the most complex part of the cluster setup. And yeah, even this is having demand because companies would go for a hybrid model or on-prem to overcome the cloud costs. So that's an option. And now if you go to AWS, there is a service called EKS, Elastic Kubernetes Service. This is called a manager service, which will help in cluster creation, but this is a paid service. But remember, 50% of the clusters in the market are EKS clusters, right? And by the way, only setups differ. Once cluster is set up, the commands, the concepts remain same. GCP offers a managed service called GKE, Google Kubernetes Engine, because Kubernetes is initially a product of Google. Google Kubernetes Engine, you can create this. I mean, it comes like a pre-package. With a single click, you can create a cluster, and it's very easy to create a cluster, and you can create broad grade cluster also. This is for free. You can create, of course, depending on the cluster resource size, you will be charged. Otherwise, it would be the service. The managed service is free. Okay. So that is one thing. So these are all the different ways. And if you know using one Kubernetes on one cloud, rest of others are similar. These are all similar. So first what we'll do is we'll do the on-prem kind of cluster setup, because that give you complete view of how you can create your cluster and work with the cluster. So first we'll go with it. But we don't have on-prem VMs and all, right? So we will take EC2 instances only. But we'll not use any managed service like EKS, and just take the raw VMs and create a cluster from the scratch, assuming they are like physical machines or something like that, right? So that's how we'll create a cluster initially, and we'll learn everything here. And whatever scenarios we can't execute with our lab setup, actually on-prem you can execute everything. With the kind of setup we do, we may not able to execute all of them. That's where we go for EKS. So that's how you will get a clarity. I mean, you get an idea on-prem as well as EKS cluster. On-prem cluster, I'll show you creation. Later on, you can also use Minikube. I'll show you Minikube cluster also. You can use this for hands-on also. That is also perfectly fine. So we'll be covering almost 3 of them. Is that clear? Any questions? Okay. So now let us go to our AWS account, have some VMs, and let's create a cluster, right? So let's get started. Any questions meanwhile from anyone? Let me create a cluster. Hmm. Logging into AWS to create some instances so that I can create a cluster with it. Okay, I'm creating new instances, and I'm going to create 2 instances. T2 micro, the key pair is AWS. Launch the instances. You can create any number of nodes. I'm creating 2, out of which one will be acting as a manager, and I mean master, and the other one as a worker. So I'm giving name as master node, worker node. Also, I would like to allow all traffic for them so that they can communicate. Going to the security group, edit the inbound rules. all traffic. Okay, so now let's create a cluster. First, let's log in, and there are some prerequisites we need to do. Let's connect to both of them. This is going to be the manager node. I have to make it manager. There are just simply two nodes. This is our worker node. I'll just change the background. Let's connect the browser. Now, okay, coming to the manager node, there were some prerequisites. It's not mandatory, but good to have. I would like to change this host name, right? So how do you change the host name? Host name CTL, set host name, master node, so that you can set the host name here. Similarly, set the worker node name, worker node 1, right? So we have set the worker node host name also as worker node name. Now they should resolve each other with their host name. So let's place those entries in etc host file. etc host. Just come here and the IP address. Master's private IP. Master node and then the worker node. Worker node's private IP. And the host name we have set for it. Right, so that they can resolve the host name with each other. I'm just copying this so that I have to place them in the other node also. Do the same here also. Etc host. Just add those entries here also. And they should resolve the names with each other, right? We have to reboot the machines for that. Before that, one more thing, this is OS specific instruction for all Red Hat and CentOS for them to communicate. We can disable the security in Linux. It works with the command set enforce 0. Here also set enforce 0, right? And then reboot the machines for all the changes to take into effect. So let's wait. We should be able to reconnect before we install other components. So now what are all the components we will install? We will install now after the systems are available, we'll be installing 4 components like Kubelet. Kubelet we have learned, right? It's a Kubernetes agent running on every node. So it's the one with which your API server will interact. So we'll install Kubelet. Docker, which should be there on every machine. Another new thing is kubectl, Kubernetes command line utility. That is the one with which you run Kubernetes commands, right? Whether your cluster is on AWS or Azure or GCP, kubectl is the utility with which you interact with your cluster. So we'll install this component as well. Docker kubectl. And then another component is kubeadm. Like I told you, this is the utility to create, right, to delete or to manage the cluster. So these are the forward utilities we will install. So these are the 4 components we'll install. Were these components clear? Okay, let's see if we can reconnect to the machine. Yes, it is back. Do you see the host name got updated? Here also, let us connect. And you can see, yes, the host name is worker node 1 and here is this component master. Now, let us install those 4 components. Right, what are those 4 components? kubeadm, kubelet, and the kubectl. So let us install them. Again, there are multiple ways to install it. Let me install it by using the binaries. I'm creating, sorry. Okay. Right, also put them onto the worker node also. Those components will be available here. Now, see what I did is I have added these repositories into yum repos file called kubernetes.repo file in yum.repos.d so that whenever you install, it will download from this mirrors or from these repositories. So let me install now. Yum install -5 Docker should be there. And I'm installing all of the specific versions of kubelet, kubectl and all. You can do the same. And do this setup on both the machines. These components should be available on all the nodes. Sorry. So the component is installed. Now enable those components. Systemctl. First start them. Start kubelet. You need to start kubelet and Docker. And then enable them. Enable kubelet and Docker. Right? Do the same on this node also. Systemctl start kubelet and Docker. Systemctl enable kubelet and Docker. Perfect. So we have enabled those components, right? All the basic components were ready. Now, how do you initialize the cluster? Like we did with the Swarm, you can initialize the cluster using kubeadm. These commands should be run from the manager, the master node. Kubeadm init API server address equal to API server address, the IP address of the master node, whichever you want to make it as a manager, master, that particular master's private IP address. Right? So this is the command. And one more thing is, for being a cluster, to create a Kubernetes cluster, these nodes should be at least having the prerequisite is each node should be having 2 CPU and 2 gigs of memory. Okay, but if you see here, we are using T2 Micro, which has only 1 CPU and 1 GIPS. That is enough for lab practice, but it will not allow as it is having some prerequisites. Also, one more thing, we can do all the hands-on here, but when you get to learn Helm and all, we need to be creating bigger nodes like T2 Medium and all. We'll see the options and alternatives at that point of time. So because we are not using the correct CPU and memory, you can ignore those errors with these ignore flags. Ignore pre-flight errors regarding CPU and memory and run the command. API server flag is incorrect. Let me correct it. API server, there is no hyphen here. On the master node, you need to run still API server. Advertise, again, that is a correction. Advertise address. So that should create a cluster. Wait for a minute and we should be seeing our cluster. You can see cluster created. Right here, you can see cluster has a control plane has initialized successfully. Cluster created, and it's giving you the token which you need to run on the other node, right, for it to add to the cluster. Let me add this. See, it says this node joined, this node has joined the cluster, right? So cluster is ready. Now you can run the commands, but before that, I have created a cluster as root user. But we can connect with any other user, right? So for it to facilitate, you have to run this command with any other user. Let me switch to EC2 user. Exit root, I become EC2 user. EC2 user, you as EC2 user create a directory called .cube, and whenever you create a cluster, kube config file is created. If you want to access this cluster with any other user, that user also should have that kube config file. So copy that kube config file and provide right permissions to it. Now EC2 user can connect to the cluster. So I would run the command. This is the first basic command, kubectl get nodes. Right? It is telling you not ready because all the components should be ready. And also one more thing is There is a network component, network plugin. There were different network plugins like Flannel, Calico, and all. We can install some network plugin. I'm installing network plugin called Calico, which will take care of networking of the cluster with a kube proxy. So just creating those components, and your cluster should be ready very soon. So this is the cluster. And also, how are those components installed? API server, scheduler, etcd and all. All of them will be installed in the form of pods. You can see that. You can see all of those in the pods format. Okay. Get pods -a means it will show you all the pods. See, they were all in pending state. Once they were all into running state, you can see your cluster nodes ready. Is that making sense? These are all the pods actually which we are talking about some time back. Of course, these are the pods for cluster components itself. Similarly, we'll create pods for our applications like address book, Nginx, and so on. Got it? Okay, now all of them running. One is error. Let's see. Let's get the pods. They were all ready. Do you see this? Right? So cluster is ready. Now you can deploy your applications onto this cluster. Any questions from anyone till this part? So if everything is good, our cluster is ready. You don't have anything to do on the worker node, only till the setup you need it. Now let's say I want to run some pod which runs Nginx. I can run this way, kubectl, sorry, run Nginx. Run Nginx, and if you want to tell on which port it's running, it's just about starting a pod. Pod name is Nginx and the image name is Nginx, right? So it will create a pod. Pod is nothing but a container. You can see get nodes and get pods. Shortcut is PO. You can see a pod. It's first in the container creating state. Slowly it came into running state. If you want to see where it is running with output wide, remember one thing. In Kubernetes, always pods will be running on the worker nodes only. Nothing will be scheduled on manager node. I mean master node. If you want to see where they're running with output wide, okay, so you can see here the IP address and the node is worker node 1. Clear everyone? Right, this is a worker node 1. That's how you can see where it is running. If you want to see more details of pod will have container, right? So if you want to see that, describe pod name is Nginx. You can see all the details. See here, running state, it's running pod IP. Every pod will be assigned with some IP address. Container ID, image ID, everything you have here. Right? The volumes. And by the way, I told you during the architecture, right? Initially, your scheduler will schedule the pod. See, scheduler has scheduled it. Kubelet will pull the image. Kubelet will start the container on that particular worker node 1. You can see it under events, right? And I have created one pod and also I have created pod with this command. This is called imperative approach. But in real time, in Kubernetes, we prefer declarative approach. What is meant by declarative approach? We write these configurations in a manifest file, and that manifest file could be written either in YAML or JSON. The best practice is to put it in the YAML. I mean, mostly we'll use YAML, so we'll use YAML here. So rather than doing this way, we can write a YAML file and deploy the pod. That's actually the right way. So we shall get started writing our manifest files from the next class. But any questions from anyone? Get nodes. Two nodes, one is a worker node, one is a master, one pod which I have deployed. And if you want to delete the pod, delete. Commands are simple, okay? Delete pod name. I'm just cleaning it. I'll create it with a manifest file by writing the manifest in YAML. How to write the manifest file, what are those manifest file, what is a pod, a lot many things. How do you scale it? How do you expose it? All of those things are coming in. Any questions from anyone till this part? Is it clear for everyone? Any questions do we have? Okay, so this is a cluster setup with the cube atom, right? Let's suppose you don't want to create a cluster, this we want to have it in your laptop. You can also do that. Let me show you that. That's a Minikube cluster. You have official documentation as well. Minikube official website. Okay, so here are the instruction steps. If you want to set up Minikube on one EC2 instance also, you can do. Here are the commands. Or else if you want to set it up on Mac, okay, or Windows, you have all the commands here. It's very easy to set up this cluster. I have already my cluster setup done. Let me launch it. How do you launch your cluster? I'm just opening another tab. This is my Mac, okay? I'm on my Mac. Simply Minikube start. But before that, your Minikube will be starting at the backend using Docker. So firstly, Docker should be started on your machine. So let me start my Docker. Minikube node will be using a Docker container. So once the Docker desktop is started, I can now Minikube start. See, it's pulling a base image. It will be creating a backend node as a container. Let it get started. See, Docker Minikube container is missing. It will create a container. Okay, it is started. You can run it as kubectl. Like any other, of course, by the way, one more thing. Kubectl should also be installed on this machine. Okay, I have it. So kubectl get nodes. Do you see only one node which will be acting as both controller node, I mean master node and the worker node, right? Simply that. But yeah, you can check everything, concepts, everything is same. See the default pods, and if you want to create any pod, kubectl, what did we do? What is the command we use to run the Nginx image? Run some name and image name, image equal to Nginx, and then port equal to 80. That's what does the command, right? See, Nginx created kubectl get pods. I can see my Nginx. This is the one just now created 6 seconds back. Clear everyone? Ignore other ones, okay? Those are the other things. Ignore this part. Got it clear? So you can use either Minikube cluster or on-prem kind of setup. If on-prem kind of setup, if you feel a bit difficult, complex, you can simply go with a Minikube cluster. It doesn't make any difference in your learning. So you can feel free, don't stuck up with a setup with a on-prem kind of setup. You can go this way also. Understood? Any questions from anyone? If no questions, we shall stop here. Tomorrow we shall get started with the actual, the hands-on part of deployments and all. Any questions from anyone? We'll meet again on Monday. Thanks everyone. One more thing, one last thing actually I want to show you is I just cleaned up everything. Okay. Now, if you have created a cluster this way, you can just stop them like any other nodes. Okay. Just go and stop them. Sorry, stop them and start them whenever you want it. Your cluster should work fine. Right? Don't leave them running unattended. Okay. I'll stop and I'll start them in the next class. That's all. All right, then. Thanks, everyone. Happy weekend. See you all on Monday morning. Bye, everyone.
Thank you, ma'am. Have a nice weekend.
Thank you.